now, we started 4 years ago, we were 12. So as you can see, we are not as big as we were now. We also do not have the experience and knowledge that we have now. So all we had was motivation, hard work, perseverance, and we had support from our mentors, and with that we were able to advance to nationals as the second best overall team in Virginia in our very first year. So in order to do...
I have a question.
Yeah.
So you talked about the best practices in engineering and project management. Could you give us some examples of that? And also, can you tell me if I could take this robot to my next mission to Jupiter?
Right, so for project management, we have a lot of different tools like Slack and Google Drive. We use Slack to communicate between our team and share documents, share information. And Google Drive is where we keep our main documents that we're all working on, and allows us to share with everybody in the team so everybody can be working on it at the same time.
Regarding your question, if you could take it to Jupiter, definitely if you attach it to the ground because of the gravity.
Great.
So the question was, so we know we programmed it on the software side, but how did we engineer it on the hardware side?
Right, so in FTC you're allowed to use different parts. There's like 3 or 4 main companies that provide parts for our robot. So we started by looking at these parts and using, as it was earlier on the screen, it was on AutoCAD. We laid out these parts and put them together to build a robot virtually. And after that, after we finalized it, we put it together in real life. So, and we also use something called the Scrum-based model. It basically means that you take the large task, break it down into smaller parts, and you attack one part at a time and make sure that each part works properly, and then you're done. So that's how we engineered our robot.
So not only did we just use parts from other companies, we also have custom parts on our robots, like that side plate right there. It's black plexiglass and it's laser cut.
What is your next step? So what's your vision?
So our vision is, as we said before, we go to different local libraries to teach the younger generation programming because they might not have the exposure that other people have. And we've also gone to different school boards, as we said before, to create teams for robotics in schools that don't have any, because maybe they're not as fortunate. And so our goal is to see many more kids involved in robotics. So the point of us doing these outreach events is to inform parents and students who are not aware of the different robotics programs they can join. So our goal is to see many more students be involved in the STEM community.
Do you want, I guess this robot doesn't have a camera, right? So I was wondering, are you planning to include one camera?
So you can't really see that at the moment, but there, as we said before, there is a phone on the robot, and that phone, we use the camera. So in this year's so the competition releases some specific tasks that we have to accomplish. One of those tasks being, there's one cube there and 2 balls in on those 3 squares. And we have to identify the yellow cube and we have to knock it off. So the way we did this was we used the phone's camera and we implemented artificial intelligence to use image recognition to be able to detect the yellow object and move it out. So we did use the camera.
Oh, fantastic. Good.